In this episode, we're going to continue looking at testing in Go. We're going to make use of the Testify test toolkit. Hi, I'm Mark Bradley and welcome to Testing All the Things, a screencast in which we use live coding to demonstrate different types of testing tools and techniques. In this episode, we're going to use the Testify toolkit. We're going to use it to add test suites and assertions to our tests. Let's look at the code. Now that we've created our test file and our implementation file, we need to start setting up the test suite in the test file. So I already have a number of templates already set up to allow me to quickly get started. So I have the Testify suite is a template which creates the suite setup for Testify. Testify test, which creates a Testify style test, and Testify setup, which creates a setup method for a suite. I will share links to the gists for each of these templates in the description of this video. So for now we need to create our suite and give it a name. So we want to call it something, so we're going to call it stack suite. We're going to create stack. There we go. And as you can see, it's added the word stack here, here, and here in the template all at the same time. So we now have a struct called stack suite, which has the Testify suite embedded into it, and then we have one normal Go test called test stack suite, which runs the suite run function, passing in the instance of testing t, and creates a new instance of the stack suite that we are about to run the test for. Now we've got the suite set up, we can add our first test. So we will create a test for the emptiness of our set. So Command J to get up my templates and Testify test. So this needs to be part of the stack suite. Now we can name our test, we will call it empty. And now we can start writing our test. So we need a stack. So s equals adt dot new stack. Okay. Okay. And I think I know what's having trouble with that actually. Let me just check in my Go mod. Yeah, look, I need that to be ADT. There we go. That seems to have solved the problem. And now we can, yep. There we go. So now we can create our new stack function. So func new stack. But as we can see in our test, we need to return something. So we're going to make that return a pointer to a stack. So let's create our stack. So that's type stack in struct. Doesn't have anything in it yet, but we can do return a stack. Okay. Okay, we've still got a complaint over here. What's happening? No new variable. Oh, I've called the variable s, which is a bit bad. So let's call it stack. Go, and now I'm not using stack. So now we need to start actually writing some test functionality. So, part of the Testify toolkit is not only the suite functionality, but it's also assertions. So it has a really nice assertion library in it, and we can access that directly through the suite. So s dot equal, there we go. So we want, well, actually we're testing for true, so let's see if there's a true. True, yep, there we go. And we want stack dot is empty. There we go. So that I personally feel is much neater than the kind of the pure Go testing approach, where you have to do if stack dot is empty does not equal true and then write the error yourself. I think this just makes it a little bit easier, a little bit quicker to write tests. So our first error is that the is empty, so we can create that method over there. It's on the pointer, it returns a boolean and nothing else. There we go. Okay, so it needs to return a boolean for it to compile, so we'll make it return false. Save. Oh, yep. Bad mate. Is empty. Spent too much time writing PHP recently. There we go. Right. Much better. Okay, so if we run our suite of tests and run. Okay, we've got a failure. Right, let's tidy up the IDE a bit. We don't need that for the rest of the day. And here we go. So what does our failure say? Here we go. So it's a nice readable error. It said should be true, but we're getting false, unfortunately. So there's a very quick and easy way to make our test pass. Here we just change this false that's returned to a true. So save. There we go. Compiling, and our test passed. And there we go. So tests are all passing and we are happy. Okay. So moving on to the next test, we want to test not empty set. So we'll create a new test function. Testify test on the stack suite, and we're going to test not empty. Okay, so stack equals new stack, and we want to do stack dot. So I recently was giving a talk about testing and found out something interesting. In the original, in a paper by Alan Turing, the original functions for adding and removing items from a stack was not push and pop, but bury and unbury. So we can use those this evening. So bury, and to make things easier, our stack will just contain some strings. So we will add red to the stack. That needs to be exported. So case B, and now we can let, there we go, create stack. Bury takes a string, call it item. There we go. Okay, so that's currently compiling, so we can go back to writing our test. So now we want to check that we get false when we call stack dot is empty. Okay, if we run the tests, okay, and we've got a failure on the not empty, so it should be false. Okay, so let's have a think about the easiest way to make this functionality pass. Well, I think it's going to be, we need to now start to trace whether our stack is empty or not. So we can do is empty and make that a bool, and then when we create it, it's defaulted to true. Spelled correctly. There we go. Okay, and then we can return stack dot is empty, and here we can do stack dot is empty equals false. So if we run our tests, that's all running and passing. And now's an opportunity to do a little bit of refactoring. I will want to just rename this. Oh, no. Just 6. Oh. No, I don't want it to do. Sorry, I just want to. No. Hang on. No, it should be there. Refactor. What is it? Rename. Yeah. All receivers. S. There you go. Make it a bit shorter. That's a bit neater. We'll just check the tests all run again. Which they do. So our refactor was fine. Okay, so we now want to move on to our next piece of functionality. I have just realized that my code's not being neat enough as I save, so I just want to go and quickly turn on file watching. Watch. There we go. Add and go import. Apply. Okay. That's better. Cool. That needs my code up nicely. Excellent. So we now have 2 tests and we have some implementation. So we're going to move on now to the next part of the functionality we want. We want to keep track of the size of our stack. So we will add a new test. Stack suite, test size. Well, test empty is empty size 0. There we go. Okay. So let's copy and paste this. There we go. And s dot. Now we didn't check equals. I don't think there's a 0. Oh, maybe there is a 0. Oh, that's useful. There we go. So adt, stack dot size. Okay. Right, let's make it compile. Stack size. It returns an int and nothing else again. Okay, so let's make it return -1. We want to fail. In fact, we need to return 1. That's fine. Run the tests, and we've got a failure. Should be 0, but was 1. There we go. So quite a simple, easy fix now. We can just change this 1 to a 0, and our test should now all pass, which they do. Okay, so now we can move on and use create another test. So rather than going for 1, we'll move on and let's make it work for 2. Speed things up a little bit. So testify test, and we want suite test 2 size 2. Okay, let's just say 2 size. There we go. That's a bit cleaner, isn't it? Okay, so stack. Let's do copy and paste job, shall we? Okay, berry red, and next one we'll add is blue. Okay, so we run this. Oh, we've got the assertion. See, that's why you always run the tests before you start writing any code, in case you make silly mistakes like that. So s dot equals now. So we are looking for 2 for the stack size. So we can now run that test, and now we should get the failure we're expecting. Not equal, so we expected 2, but we actually got 0. So let's go ahead and make those changes. So we now need to keep track of the size of our stack as we add new things into it. So we can create another field on the struct, so we'll call it size, and that will be an int. And when we add things to the stack, so s.size, we increment, and then we return this s.size. Brilliant. So that was nice and simple. Now if we run tests, I've got a mistake. Too few values in. Yep. I forgot to add default size. There we go. In there, so we run it again, and now we're green. Excellent. Okay. So we've now got a bit of a chance to do some refactoring. So in the implementation code, we've kind of got duplication of information, because we can deter that if the stack has a size of 0, it is empty. So we don't need to keep hold of the boolean and the integer. So if we change the implementation of our isEmpty to return s.size equals 0 and run our tests, that worked, which means we can now remove this line of code, and we can remove this line of code. And we forgot to update the new function. Now it just takes one. And our tests all passed. But there's also now an opportunity to do a little bit of refactoring on our test side as well. So I mentioned at the beginning that the suite functionality of Testify allows you to add a setup function. So if we add that now, so J Testify setup, and it's assigned to the stack suite, and the function is called setup test. This function is called by Testify just before it runs each of our tests, so it gives us access to set up things just before each test is run, so each of the tests in our suite. Now currently in every one of our tests we create a new instance of the stack, which is maybe not exactly what we want. So what we could do is we could add a stack, and it's pointer to a stack, tstack. There we go. Okay, so now we've got the ability to, in our here we can do s.stack equals it equals a new stack like this. Copy, and hopefully we should be able to, let's test just with one test, remove this line and use the stack in the test, that, and then we'll run the test and see if it all passes, which it does. So we can now do that throughout each of our tests. So start. There we go. Okay, so I know that only removes a couple of lines from our tests, and it's very simple, but it gives a nice little demonstration of how the setup function adds a lot of power to your test suites, and is one of the reasons I really like the Testify toolbox. Right, let's carry on implementing the functionality of our stack. So Now that we have got the ability to know the emptiness of our stack and the size, we now want to start to be able to take things off of our stack. So we can add a new test function. J testify test. So we will test unbury. Okay, so we need to add one thing onto our stack. And then we want to take it back off again. So we want to check that when we check the thing we take off. So equal is the last thing we added, so it should be red when we s.stack. Oh, should be a comma. There we go. S.stack dot unbury. So it should return the thing that sits on the top of our stack, and that should mean that s dot equal s dot 0 is the stack size, and let's be really good and check that's false. No, true for stack is empty. So at the moment we know that if the size is 0, then it will be empty, and that's but that's down to we know the implementation. So we can. This allows us to check that the implementation of both the size and the empty function continue to work. We can pretty much assume they will, but we don't want to make that assumption when we're writing tests. So we've got our unbury function, which needs to be created before we can run the tests. So yep, and that returns a string. Oh no, I'll struct a string. Go, and if we run that, oh, so we're missing return. So return empty string, and then we run. Okay, and this works. Well, it doesn't work, it fails. And it fails as we expect. We expected red, but we got an empty string. So there's an easy way to make that pass. Red, and let's run the tests. Okay, so what's happening now? Well, so we're expecting the size to be 0, but it was 1. So we need to decrement the size for return. So size minus, and run it. And there we go. So that works. But obviously our implementation is not complete yet. So let's give this test a better name, a single item. Okay, right. And let's create a next test. So J testify test stack and test unbury multiple items. Okay, so we'll add 2 things to our stack, and take so we need to the first thing off. So s equal, so the last thing on should be the first thing off. So we're looking for blue this time. When we unbury, okay, and we should check the size. So s dot equal 1. S dot stack size. Okay, And then we want to unbury the second item, and we should just be able to repeat this. There we go. Okay. Right. So we can run our tests, and we're failing again. And we're failing because, yeah, there we go. Takes me to the right bit. We expected blue, but we actually got red. Well, that's not surprising because we had this hard-coded red here for the return value. Now is the time we need to start adding the functionality to actually keep track of what's added to our stack. So we'll use an array for today to make it nice and simple. So it's going to be called items, and it will be a string. And let's just give it a size of 6 so that it will work for all of our examples. And then we need to do there we go. Okay, so we now have something we can store our items in as they are added. So as we add things, we can assign them to our array. So s.item equal, and we'll add it into the s.size location equals item. There we go. Okay. And now this allows us to return the last item added. We can know that is at should be in the location of the decremented size -1. So what we can do is we can decrement the size and just do return s dot item at s dot size. Okay, I think that should work. Let's play it. Yep, and all our tests are passing. So we will just do a quick little refactor and name that items. It's a bit neater, and test everything's working. And that's the end of the demonstration of Testify for now. There are obviously a lot more assertion functions available to you to use. I suggest you can have a play with that. We will definitely be making use more of Testify in later videos. But for now, is everything.
Thank you for watching this episode of Testing All the Things. I hope you found it useful. If you enjoyed it, please rate the video and subscribe to the channel. If you did not, please leave constructive feedback in the comments. If you would like to suggest something you would like covered in a future episode, please leave a comment as well. I'm Mark Bradley. You can follow me on Twitter at @Braddle, or if you're just interested in all things testing, then follow @TestingAllThe.